All right, guys, let's do our sectional multiplication. So we did addition and subtraction, and today we're going to talk about multiplication through various models. So you have the repeated addition model, which is the most common when you're describing what multiplication is for the first time to an elementary student. We talked about how when you add something repeatedly, you can think of that as multiplication, and you can visualize that as an array. Let's see. If we have 4 groups of 3 brushes, we can use addition to put those groups together. When we put the equal size groups together, we can use multiplication. So 4 threes is like 3 plus 3 plus 3 plus 3, which is 12, or 4 times 3. This is another visual, a couple different visuals. So 5 times 4, you can see that you have this way of thinking about it, right? 5 fours right here. Or you can have 4 fives, which they labeled as 2 tens. For any whole number, a, and natural number n times a is a plus a plus a n times. So here are two different, there's an array model right here, which is the dots. And then there is the area model, when you think of, when you actually find the area of something, it's like how much space it occupies, or how many squares. So like square centimeters, square inches, square units in general. So that is how you can illustrate area. Suppose you plan to take 2 web-based courses at your local college. You can take one of the following: world history, ancient history, and then for your second course, you can take Latin, French, or German. So here's a way where you would have to use multiplication to see the different options you have. And so you have 2 history options and then 3 language options. So there's time you can write these as a set, and then you could do it as a tree if you wanted, where you can either take world history and then Latin, or world history and then German, world history then French, or ancient history with each of those options. So you have a total of 6 options, which you can figure out by doing 3 times 2. And the finite sets A and B. N of A is the number of units in A, and N of B is the number of elements in B, and A times B is the number of elements A times B. This is similar to the addition properties, the closure property of multiplication. So if A and B are unique whole numbers, and you multiply them, you get a unique whole number. The commutative property means that you can commute, right? The order doesn't matter. A times B is the same as B times A, so 2 times 5, same as 5 times 10. Associative property means you can rearrange if you have just a string of things you're multiplying. If it's easier for you to multiply 2 things together and then something else, it doesn't matter which ones you multiply first. The identity property for multiplication is 1. Is anything times itself. I mean, anything times 1 is itself. And then multiplication property is 0. A times 0 is 0. Here are illustrations of the commutative property and the associative property. Now, the distributive property is very important. I feel like even some students that I tutor that are in upper level math can struggle with this concept of distribute. So when you have 5 times the group of 3 plus 4, it's really 5 threes plus 5 fours. You cannot forget to distribute this to both of these things. Let's see what's next. So that's just illustrating the distributive property. A times B plus C is A times B plus A times C. Same for subtraction. And then this is the distributive property. Again, you can distribute it into multiple terms. This is talking about factoring. So if they have a common factor, this is like kind of going backwards. So it's the opposite of distributing. Now you're like, if they have something in common, you can pull it out front. That is called factor. Using the area model to show that x plus y is equal to, times z plus w is equal to these terms here. So this is one way to illustrate that. We have x plus y here, and then z plus w here, and then multiplying x times z is xz, y times z is yz, x times w is xw, and y times w is yw. And then you would just sum up these terms. So you see you have 4 terms here, which are these guys right here. And that's one way to illustrate what you're doing when you're multiplying. It's called binomials. So use the distributed property multiplication to show that. So this is another way of doing it. We're distributing z to both of these things and w to both of these things. You might have heard it as FOIL, or you might have done it as the box method, but I always did first and then outside, inside, last to get these terms here. You're distributing every combination of those four products. A to the n is a times a times a, n times. A to the 1 is a. When you have exponents and you're multiplying the exponents, you can put them together. I think it's always helpful to think through an example, especially when you do this. If I have x squared times x cubed, this right here really just means 2x's, and this right here really means that you have 3x's. So altogether, how many x's do I have? I have x to the 5th. So when you're raising things individually, a to the n times a to the n, it's a to the sum of n plus n. This is different. This one is the multiplication property. So if I have x squared cubed, which what this means is that I have 3 of these guys. So you have x squared, x squared, x squared, which then you have 3 too. So that's x to the 6th. So when you have a power to a power, power to power, multiply. This is just something you can take the exponent and distribute it to both terms. When you are dividing, I don't like it written that way, but so this is like I've had x to the 4th over x squared. X to the 4th is like 4x's, right? And x squared is like 2x's. So they cancel out to just give us x squared. But a really easy way to see that is that you subtract. So a to the n divided by a to the n is a to the n minus n. And here, this is just saying if they're both raised to the same power, you can put them in parentheses and say that the group is raised to that power. And they have to be raised to the same power to do that. Right, each of the following is one exponent. Okay, so this is where you have to think critical thinking here. You have to think through what common base do they have. So 8 is the same as 2 cubed, and 16 is the same as 2 to the 4th. So we have 2 to the 6th, and then we have 2 cubed to the 5th, and we have 2 to the 4th to the 3rd. And then I can multiply power to power. I multiply, which is what they got here, 15, 20. And then when we have the same base, do you remember we add these exponents because it's like I have 6 2's, 15 2's, and 12 2's. So then we sum them all up and we get 33. So that's applying some of those different properties of exponents that we just went over. Here's multiplication algorithms. If I'm illustrating 3 times 13, this is one way of thinking about it. So I have 3 times a 10, that gives me 30. And then I got 3 times a 3, that gives me 9. So I have 30. This is illustrating another multiplication algorithm. This is multiplication as extended addition, expanded addition. So they're taking each, it's basically using place value. So this guy here is in the hundreds place. So this just means 100, right? Because this right here is like 300 plus 60 plus 7. So they're saying I'm going to take 4 times 3 times the 100, which is 1200, and then 6 times the 10, which is 4 times that. So that's 240. And then 4 times 7 is 28. And then you add them all together. Multiplication with 2-digit factors. So here they're doing an illustration of it, but also, let me explain this. This is 4 times 3, so that's where we get 12. How did they get this 80? Well, this 80 is knowing that this is actually a 20. It's not a 2. It's in the tens place, so it's actually 20 times 4. So right here, this is 20 times 4, so we got 80. Then they have 10. This is 10 times 3, which is 30. And then they have 20 times 10, which is the 200. So that is being really careful with place value and determining, is it 20 or is it a 2? And then summing them together. This is another way of doing it. We showed this with addition model 2. So if I have 23 and 14 and I multiply, so I don't really ever see this used, but this is another way of thinking about it. 4 times 2 is 8. 2 times 1 is 2. 3 times 4 is 12. 3 times 1 is 0, 3. Then you go across like this to add. So 2 is just 2. 8, 9, 10, 11, 12. So I put the 2 here and carry the 1 up here. 2, 3. And so then I have 322. That's kind of a fun little way to think about it. I've never really seen it that way, but that's another way to do it. Let's see the base 5 multiplication table, which is similar to our concept of addition, but we have 21 times 3, 20 plus 1 times 3. 3 times 2 is 6, but we don't have 6 in base 10. Like, look over here. So 3 times 2 is 11. So then that's why we have 110, because it's 11 and then the 0 right here, and then plus 3 times 1 is 3, so we have 113. And this is showing you an example in base 2. So 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, and then we add them together. This is using place value again, so I have 70 times 4, and then 8 times 4, and then I sum them together. Or this is another way of thinking about it, where I have 2 times 5, 40 times 5. Okay, so they're showing you can group them differently if you're trying to do it mentally. So if I'm trying to find out the string of numbers, I don't have to multiply them in that order. I don't have to say 2 times 8 is 16. What's 16 times 5? Instead, you could say, oh, I know 2 times 5 is 10. I know 40 times 5, that's 200. And then I can just say 2 times 1, that's 2,000, and then multiply by 8. So it's a little bit easier if you group it to your advantage. And then this is the of monies, like 25 is like, of course, 25 cents, like a quarter. So you could think through it like that if you're good with money. This is estimating. So that's 400 times 9, 70 times 9. And so they just left out the ones place there. All right, so that's some different high level how to teach multiplication, how to think about multiplication when you're presenting it to your students. So attempt the assignment, and as always, please get back to me if you have any questions.